In this module, you have learned about speed and acceleration. The lab linear motion will then let you explore in more detail the ideas of constant speed and constant acceleration. Also, you will learn to not only understand the difference between these two types of motion, but also be able to identify them using graphs of motion. This applet is pretty easy to use. If you want to set the position or the velocity of the acceleration, you use the slider bars. So for instance, in the very first part of this, you set this at 1 meter, and then you set it with an initial velocity of 2 meters per second and no acceleration. So if something is not accelerating, that means it's not getting any faster. So if you were traveling at a constant 2 meters per second, then that means that every second you'll go 2 meters. So what does that look like in terms of graphs? So if we press go here, you'll notice that for something that's traveling at a constant speed of 2 meters per second, every second it goes 2 meters. So if I look at the position graph, after 1 second it's gone 2 meters. After 2 seconds it's gone 4 meters, and so forth. So if I look at that graph, it's a straight line. But now if I graph the velocity as a function of time, in other words, how is the velocity changing with time? Well, it's a constant velocity, and that velocity is at 2. It never changes, so the graph for velocity is a flat line staying at 2 meters per second. And of course, since it's not getting any faster, there's not going to be any slope on the acceleration graph. Let's just concentrate on this position graph though. So if something's traveling at a constant velocity, it means its distance is changing at a constant rate. If it's changing at a constant rate, that means that the slope of the position or distance graph will be a constant slope. But what happens if it's not traveling at all? What if it just sits straight at 1 meter? What would that look like? So if we press go there, Inga's velocity and acceleration are both 0. She never leaves the starting block. So she never leaves the starting block. So if we were actually going to time this, it would just plot as 1 meter straight across. Now let's look at an acceleration. Let's say she starts from rest and she accelerates at 1 meter per second every second. Or let's do 0.1 meter per second every second. And let's give her that initial speed of 2. What does that mean? It means that now she's going to get faster every second. So remember that the slope of a position graph gives you the velocity. If the slope is constant, then that means you're traveling at constant velocity. But if the slope is changing, if it gets steeper, you get faster. If it gets more shallow or flatter, you get slower. So if I look at this and I say, okay, I'm getting faster by 0.1 meters per second every second. So after 1 second, I'm not going to be going 2 meters per second. I'm going to be going 2.1. And after 2 seconds, I'm going to be going for 2.2, and then 2.3, and so forth. So let's press go. Notice that the graph now doesn't look exactly straight anymore. And if we put even more acceleration on there, if you look, the graph looks curvy, right? It looks kind of like a straight line, but it really does have a little bit of a curve to it. Let me put it down at a little lower velocity so we can look at it. There we go. Let's say we start from 0. So now we can really see that curve because there's been a very big change in speed. Notice that every instant in time you travel further and further and further and further, right? Because you're going faster and faster and faster. So the distance or position graph looks like a parabola, a curve. But yet look at the velocity graph. You're changing your speed by the same amount every time. So the slope is constant. And of course the acceleration, that's the rate that you're changing by. I'm changing by 0.2 every second. My speed goes up by 0.2. That is not changing, right? That's a constant rate. So you're going to be exploring this in this lab. Please email me if you have questions.